Okay, we're back for more examples. So the next one should be pretty straightforward. Hopefully you were able, to solve that. So a committee of 3 is to be chosen from a group of 13. How many ways of choosing committee are there? Well, it just has a committee of 3. It doesn't label them as having certain responsibilities or certain titles. Therefore, it is a combination, which means order doesn't matter, which means it should be a smaller number of a result. Or it's just 13C, combination 3. Use your calculator, you get 120 different ways. Now look at these last two. They're a little more complicated, but once you see one and kind of get the hang of it, hopefully you'll notice what is happening, how you're grouping them together, and then it's not really so complicated anymore. So we have a catering service that can prepare 6 different soups, 8 different salads, 8 different vegetables, and 10 different entrees. And how many different ways can you select 1 soup from these 6, 3 salads from these 8, 4 vegetables from the 8, and 2 entrees from the 10 entrees? So the order of the salads, it doesn't matter. You're just choosing 3 of the salads out of the 8. The order of the vegetables, it doesn't matter. You're choosing 4 of the 8 vegetables. So all of those are combinations. But notice the categories. Soups have to go with soups. Salads have to go with salads. Vegetables have to go with vegetables. So we're choosing 1 salad out of the 6 possibilities. We're choosing 1 soup out of the 6 possibilities. 3 salads out of the 8 possibilities. 4 vegetables out of the 8 possibilities. 2 entrees out of the 10 possibilities. Now remember, what are you saying? What word would you use? Would you say we're going to have 1 soup or 3 salads or 4 vegetables or 2 entrees? No, you should be saying the word and. You want this and this and this and this. And so we want to have 1 soup, and we want to have 4 salads, and we want to have 4 vegetables, and we want to have 2 entrees. And whenever we use the word and, we have to multiply those results by each other. So when you plug into the calculator, you should have gotten 6 for this one, 56 for the second, 70 different ways for the vegetables, and 45 different ways for the entrees. And then we're going to multiply those numbers together, which I'm doing now. And I get 1,058,400 different combinations that we could order if we just wanted to choose 1 soup, 3 salads, 4 vegetables, and 2 entrees. Pretty amazing, huh? You wouldn't think that when you went and made that decision yourself, that you had so many different ways you could do it. But you do. Okay, so look at this example. Maybe you want to pause now and figure out the next one, try the next one on your own, because it's going to be very similar. So we have a standard deck of playing cards. There's 52 cards, right, in a standard deck. In that standard deck, 13 of those cards are spades, 13 are hearts, 13 are diamonds, 13 are clubs. You have 4 kings, 4 queens, 4 sevens, 4 jacks, 4 aces, 4 twos, etc. 1 of each suit, right? It says how many different 5-card hands are possible? Well, the order in which you get the cards in your 5-card hand, it doesn't matter. So once again, it's a combination. Well, we're choosing 5 cards out of how many different cards? There's 52 of them. So we're choosing any 5 cards out of the 52 total. So we're going to use our calculator. Do 52, choose 5. And this is my result. I get 2,598,960 different possible hands. Okay, so let's look at the second question. The second question says, how many of the hands in part A contain only spades? Okay, that's getting a little trickier. But look at these categories up here. Remember, we took a category, we took the total in that category and how many we were choosing from that category. Well, we have a category of spades, right? And in the category of spades, there are 13 cards. And how many do we need to choose to get a hand of 5 that is only spades? Well, you need to choose 5 cards, but there's only 13 options for those 5 cards. So it's 13 spades, we're choosing 5 of them. Right? If this would have been true for any of them. What if this word could have been hearts? It still would have been 13, choose 5. This word could have been diamonds. It still would have been 13, choose 5. Or it could have been clubs, it would have been 13 choose 5. Now what would it have been if I had said how many of the hands in part A have only red cards? Then how many red cards would we have had? We would have had 26 red cards, choosing 5 of them. Or if I said black cards, it would have been 26 choose 5. But again, the category was just spades, so I'm limiting it to just the spades, so that's why 13 choose 5. Finally, it says, what is the probability of getting a 5-card hand that is all spades? So probability, remember probability? That's our fraction. The numerator is the possibilities of getting the all spades, which was 1,287. And our denominator was all possibilities of getting a 5-card hand. So all the different ways. So that's 2,598,960. So we divide those two numbers by each other. Sorry, I'm a little slow. And I get 4.952 times 10 to the negative 4th power. Or what is the chance of that happening? It's about 0.00049552. Right, 1, 2, 3, 4, yep. So it's a very slim possibility. So please look through the work. If you have questions, ask me during class if you had any questions about the notes. Otherwise, I'll just see you in class to practice with the homework or with the assignment that's from the book, and we'll go from there. See you soon.